Lesson 73. More on radical denominators. A few lessons back, we talked about radical denominators. It was one of the lessons I taped at school writing on the whiteboard because I remember drawing the little picture of the hippie dude to be my radical. And we talked about a weird word called conjugates. And we talked about how conjugates are pairs of two-part expressions that are exactly the same except for the minus sign in the middle. And just to remind us, we use this simple version of a pair of conjugates. Notice that they're exactly the same except for that middle sign. And the cool thing about them is that when we multiply them, they reduce from three terms to two terms. Well, the middle term disappears, and we get this nice simple expression, and it's a great way to deal with radicals in our denominators because we can make square roots go away. And of course, remember that as mathematicians, we do not like radicals in our denominators. Upstairs is one thing, we can live with that, but no square roots downstairs. So we did some problems that looked more or less like this, where we had a two-part expression in the denominator, and we used the conjugate. Remember, we would multiply it like this to make it go away. If you do it to the bottom, you do it to the top. And that was no problem. We learned how we did that, and then we would distribute if need be. What we're going to do in lesson 73 to up our game a little bit more is that instead of just having cute little simple numerators, we're going to, you guessed it, have wicked things in our numerators, like so. So we're going to put radicals upstairs too, and we're going to try a problem that looks like that. They really don't get any harder than this, you guys. This is basically the way it works. So the same principle applies. Step 1, multiply both top and bottom, numerator and denominator, by conjugate of the bottom. Again, I mean denominator, but I'm saying bottom. It sometimes confuses students because they go, wait, conjugate of the top or conjugate of the bottom? And we want the conjugate of the bottom because we're trying to eliminate the radical in the denominator. So that's why we always choose the bottom, because we want to get rid of that dog. So we multiply this by the conjugate, which is 2 plus 3 times the square root of 3. So just like a lot of our problems, we start with the bottom and we work our way up. So now we've got conjugates. We know that that will simplify. We're multiplying. What we do to the bottom, we must do to the top, right? Okay, let's look at the bottom first and make sure that we satisfactorily wipe that out. I'm going to work in this little space here and show that if we've got this format, we can use this summary to work this out. So we will have, this will equal 4, oh, see, I said 2 squared, but then I cheated and told you the answer. 2 squared minus 3 times the square root of 3 squared. So that will be 4 minus 9 times 3. So that would be 4 minus 27. And 4 minus 27 is minus 23. Okay? So our new denominator, when we multiply this pair of conjugates, is going to be minus 23. That's the good news. So here's what I'm going to do. I'm going to put my answer over here, minus 23, and I'll put a box around it so I've got space to write my top in there. Now, we still have to deal with this multiplication on the top, but we just handle that as we multiply a pair of any two-part expressions. We're just going to do it like we did our friendly binomials. So I'm going to write the two pairs of two-part expressions, stacking them. There's my line, and now I'm just going to multiply. 4 times 2 is 8. 2 times the square root of 3 is 2 times the square root of 3. This boy times the 4 is 12 square root of 3, and notice I stack them so that I'll add my square roots of 3, and then when I multiply this by this, I will get, I'm going to put my positive down, I'm going to get this 3, and then when I multiply the 2 3's inside the house, I'll get 1 3 out of the house. So I write that one like so. This represents this guy, and this came from that pair of radicals. Make sense? Yes. Okay, I'll keep going. So then, draw our line to summarize. This changes into a 9. I'm going to circle that and cross that out. Now I can combine the 9 and the 8 and get 17 plus 14 times the square root of 3. Remember, we don't have to add or multiply anything like that. They're just like x's or y's. They just come along for the ride. And so our final answer is, it can be written in this format. That is a perfectly acceptable version of this, to leave the minus sign down there. Or the other thing we can do, if we want to, that's a little bit more commonly seen, is we can bring the minus sign, I guess this is the way I would think of it. Let's pull it out. These minus ones can be tricky to handle. We have factored the minus away from the 23 by putting it out here. So we can call it minus 1 over 1. We factored it out from here. Now let's distribute it across the top so that we don't have anything on the outside. This is kind of weird, but just watch and see what it does. We'll end up with minus 17 plus, minus, because we're distributing that, minus 14 times the square root of 3 over, now it's just a plain 23. This is another form of the answer. Equally correct. This is probably more logical, following the flow of the problem. This is a little bit more standardized in the world of mathematics. But I want you to understand how to be able to flip back and forth between those so that it doesn't mess you up to see your answer in one form or the other. All right, straightforward. Let me give you 2 problems to do. They're in your book. Example 73.2 is very straightforward. 4 minus the square root of 2 over 4 plus 3 times the square root of 2. And our steps will be exactly the same. Multiply both the top and bottom by the conjugate of the bottom. And then, see, I always forget to finish my steps when I write it on the paper. And then we, I guess that's all really there is to it. You just simplify, which is kind of an obvious step. But in any case, we'll multiply by the conjugate again. Same 2-part expression, flipping the sign. Okay, I'm helping too much. I'm going to stop now. Remember, we're multiplying. So go ahead and do 73.2, but let me just show you example 73.3 is no harder, but let me just show you what it looks like before I talk about it. It's a little bit more complicated in that we don't have the very same number inside the radical signs. Before, well, no, I guess we mixed them up there too. This one is going to involve a little bit more simplifying. Once you get all of your numbers multiplied, you'll be able to, like for example, the 12 will break down and you'll be able to pull out the 4 and the 3 and then the pair of 2's. So this will require simplifying your radicals a little bit more. So I'm just going to write you a note. Simplify your radicals. And that inspires me to draw one more little zoned out hippie dude. He's got his headband on. And he's sitting on the steps in Washington, D.C. He's kind of chill. He's got a beard. He definitely needs a beard. Okay, and here's his mustache and his sideburns. Okay? He's simple. He doesn't like to be complicated. He's a simple radical, so please, by all means, simplify your radicals as well. And you know what he'll say? Peace. Okay, bye.